All right, so we have another example where we're trying to determine if we are looking at equivalent expressions. So they say determine if the expressions 1/10 z plus 2 and -3/5 times 1/9 times z minus 10/3 plus 2/15 z are equivalent. So what we're going to do is look at them as two expressions. We're going to simplify them if we need to, and then we're going to compare the two expressions. So this here is one expression, 1/10 z plus 2, and our second expression is going to be this one here. So looking at our first expression, 1/10 z, so we have 1/10 z plus 2. This is already simplified. We can't simplify it anymore. We have a value for our z's. We also have a term for, I'm sorry, not a value. We have a term for our z's, and then we also have a term listed for our constant. So we don't need to do anything else to that one. So what we're going to do now is look at the second expression, which is going to be the -3/5. Let me take that off. So -3/5 times 1/9 z minus 10/3. And then we're going to add 2/15 z. Okay. All right. So the first thing we need to do is take care of the distributive property. Remember, if you don't see a number outside of the parentheses, you're assuming that you're multiplying by 1. However, we see a -3/5. So we're multiplying each of the terms within the parentheses by -3/5. All right. So the first thing that we're going to do is just multiply um, 3 times 1 because we're multiplying fractions. So fractions, remember, you just multiply across. 3 times 1 is 3. 5 times 9 is 45. Okay, and this is z. And then we have a negative, we have a positive, so this is going to become a negative. And then here we have 3/5 times 10/3, so 3 times 10, that's 30. 5 times 3 is 15. We have a negative times a negative, that gives us a positive. And then we're going to add in our 2/15 z. So the next thing that I would do is try to simplify your fractions, right? See if you can reduce them. I see that looking at my 3/15ths, I'm sorry, 3/45, 45ths, I could divide both my numerator and my denominator by 3, right? And if I do that, 3 divided by 3 is 1, 45 divided by 3 is 15, right? So this now becomes -1/15 times z. And then 30/15ths, I know that I can divide both of them by 15. So 30 divided by 15 gives me 2, and 15 divided by 15 gives me 1. So this is the same thing as 2 wholes. Okay, so what we have is plus 2, and then we're going to add 2/15 z. All right, so now what terms will we need? Well, we know we need a term for our z's. We also need a constant, and then this one is going to go under our z. So now I'm just going to place everything where they need to go. So the -1/15 z is going to go here, -1/15 z. And then our constant, a +2, is going to go over here under the constants. And then we have a +2/15. So +2/15 z. And then what we do is just simply simplify it. So notice that we're going in opposite directions. So again, you're going to use subtraction. I notice that we have the same denominator, which is good when you're adding and subtracting fractions. You want the same denominator. So all we have to do now is just set it up. In other words, our larger number is first. So that would be 2. I'm just using the numerator because the denominator, remember, is going to stay the same. So 2 minus 1, this gives me 1. Right? My 15th will stay in the denominator, and we're talking about our z's. And then we're looking at our larger number, which was a 2. So what type of sign did we have attached there? That's going to be a positive. And then you'll have over here +2, and there's nothing else listed here. So you're just bringing that down, +2. Okay. So I don't need this plus sign over here, so I'm just going to take this out. So this expression is equivalent to 1/15 z, or simplified to 1/15 z plus 2. Now let's look and compare that to what we started off with. It was 1/10 z plus 2. So they are not equivalent because here it's 1/10 and here it's 1/15. So they are not equivalent. Not equivalent. Meaning that they are not equal to one another.